me just share my thoughts on air pollution sources and impacts and what is happening in Indian context for its control. And I'm sure some part of it must be useful for you, and something must be supplementary or complementary to what you have already heard from previous speakers. So, just starting from what are air pollutants and what are the types of air pollutants, what kind of impacts they can pose. I think this is one close to comprehensive picture, which actually shows, that it all starts with the energy use, uh, whether you're burning coal in the power plants, or you're burning furnace oil in industries, or you're burning petrol or diesel in your cars. It all leads to a variety of emissions of different kinds of pollutants. Now, pollutants can be categorized into two broad categories: particles and gases. And particles can be of different size. They can, in Indian standards, they have been categorized in two categories. The particles which are less than 10 microns are known as PM10, and the particles which are less than 2.5 microns are known as PM2.5. On the gaseous side, you have pollutants like sulfur dioxide, carbon monoxide, nitrogen oxides, non-methane, volatile organic compounds, and all these pollutants they actually make a cocktail of pollution, which is inhaled by humans, which actually exposes buildings to several types of impacts, and also impacts the vegetation and ecology around us. Now, some of these particles are quite harmful for human health. Not all are equally toxic, but some of these particles have the potential to cause serious damage to our respiratory systems, to our cardiovascular systems, and some are known carcinogens. Now, interestingly, there are some particles which are released directly from the sources, and then there are some which are formed in the atmosphere by chemical reactions between different gases. For an example, a gas like nitrogen oxides, it sort of reacts with the ammonia, and you get ammonium nitrate as a new particle formed in the atmosphere, and it adds to the pollution mass of PM2.5. Similarly, volatile organic compounds, they also result in formation of secondary organics and get into particulate form and add to the overall mass of particulates observed in the ambient air. So, in nutshell, what I'm trying to tell you is not only the pollution is directly released from the sources, but it is also created in the atmosphere due to several reactions. The pollution which is directly released, these pollutants are known as primary pollutants, while the pollutants which are formed in the atmosphere are known as secondary pollutants. Another secondary pollutant which comes to my mind is ozone. As you can see in this picture, in the presence of sunlight, when NOx and VOCs react, they form ozone. Now, in our I think fifth or sixth standard, we have learned this, that ozone is something which saves us from the harmful ultraviolet radiations of sun. Well, that's quite true, but that is basically happening in the stratospheric layer of atmosphere. That means at least 20-25 kilometers up from this place. Now, same ozone, when it gets formed at the ground level, it is quite injurious to human health, and it is much more detrimental to the growth of agricultural crops. So, in addition to impacts on human health, in addition to impacts on buildings, what we see is retardation of agricultural growth, and the crop productivity has gone down, and ozone is one of the major pollutants which has resulted in this kind of an impact. Now, all these impacts, health, buildings, agriculture, are quite local in nature, but there is a much larger impact which is impacting the whole planet, and we know this as climate change. And while majorly climate change is caused by the greenhouse gases like CO2, which are basically inert, but there are several air pollutants like black carbon, like ozone, like methane. They also have potential to warm the planet, and that is why they are known as short-lived climate pollutants. That means they not only can act as air pollutants and impact human health, but they also have a potential of warming the planet and changing the climate. So this is a broad plethora of air pollutants, greenhouse gases, and their impacts. And this slide is a very complex slide. I will not even attempt to go into details of this, but this is something. This is actually showing what I just explained. There are some sources which directly emit particles, like industries, like construction dust, but the gases released from these sources, they react in the atmosphere and form new pollutants like ozone, like ammonium nitrate, like secondary organics, like ammonium sulfate. Some of them become gaseous secondary pollutants like ozone and ammonium nitrate, ammonium sulfate. They add to the particulate matter concentrations which you observe at your monitoring stations. So this is a broad list of all the pollutants which are impactful to human life, their sources and their possible effects. If I talk about sources of nitrogen dioxide, see, nitrogen dioxide is something which is produced when high temperature combustion is happening. So if you just burn a matchstick, you will not get huge amounts of NO2 or NO. But if you burn diesel in vehicles, in cars or trucks, then the temperature of combustion is very high, and this actually leads to conversion of atmospherical nitrogen into NO, and this NO further reacts or oxidize into NO2. So NO and NO2 combinedly are known as NOx, along with N2O, which is an inert gas, greenhouse gas. But the short point here is that NOx is produced whenever there is combustion happening at a very high temperature. So that means the primary sources of NOx are vehicles, diesel generators, and coal-based power plants where a high temperature combustion of fuels is happening. Well, it has impacts of reduced lung function growth and other common impacts over respiratory systems. But the more potent pollutant is particulate matter, and the problem with this is that it comes from almost all the sources. I mean, it's not like NOx which is only limited to high temperature combustion. Even if the combustion temperature is low, particulate matter is bound to come in plenty. In fact, more at lower temperatures. So the sources of pollution, particulate matter pollution, are vehicles, industries, biomass burning, road dust, construction, DG sets, refuse burning. All sources emit particulate matter, but the difference is in the size of particles released from different sources, and also the chemical properties of particles which are released by different sources. Carbon monoxide is a pollutant which is formed whenever there is an incomplete combustion of fuel, and gasoline vehicles, petrol vehicles are known for high carbon monoxide emissions. Carbon monoxide is also released when wood combustion happens in rural kitchens, and refuse burning happens. So whenever the combustion is not efficient, the combustion is not complete, so CO2 is not formed. In fact, it stops at CO, which is carbon monoxide, and it is a quite disturbing gas, and it reduces the overall oxygen carrying capacity of the blood, and it basically forms carboxyl hemoglobin, and it can be quite detrimental if the dose of the pollutant is very high. Sulfur dioxide is a pollutant which is formed only when the sulfur is present in the fuel. And you may be knowing that fuels like coal, fuels like furnace oil, fuels like diesel, all of them have some amount of sulfur in them. And when they are burnt, so the sulfur present in these fuels is oxidized to SO2, and this SO2 is an respiratory irritant, and more importantly, it can cause acid rain. So after reacting in the atmosphere with water, it can convert into sulfuric acid and can lead to acid rains. And then sulfuric acid can further be neutralized by ammonia to form ammonium sulfate, which acts as secondary particles. Other than sulfur dioxide, you have pollutants like lead, which is now almost eliminated from our gasoline. 20 years back, India was dealing with this problem of high leaded petrol, but now the petrol which you get is unleaded, and lead has been removed from constituents of gasoline in the country and in many parts of the world. Other than this, there are other pollutants like benzene, butadiene. Now, these are actually hydrocarbons and are part of our fuels like petrol and diesel. And they're also known carcinogens. I mean, exposure to these fumes can lead to deadly diseases like cancer and other problems. And then, of course, ozone, I already talked about. It forms with the reactions of NOx and VOC, but only in the presence of sunlight. Now, that's a very important point to note, that ozone will not get formed if the sunlight is not there. The sunlight is required to form ozone at the ground level. And as I said, it is not only responsible for health problems, it is more damaging for plants and for crop productivity. Now let's see what is the state of air quality in India. If you see this map of air quality map of the world, you will find that air quality in India is not good. If you just see the levels we have in the country are quite high, in the range of 70 to 80 micrograms on an average basis. Some areas are more polluted, which is not depicted here. But the moment you shift your focus to this chart on the right hand side, you'll find that the whole Indo-Gangetic plain, starting from Haryana and Punjab to UP to Bihar to West Bengal, is very heavily polluted. The place where you are sitting in Surat is also not very, very clean, I must say, but is relatively cleaner than the Indo-Gangetic plains. But I think there are plenty of sources in Surat, and I had the pleasure of working in Surat to understand the source contributions. And within next 2 months, you will get the first source apportionment report for the city of Surat, which not only assesses what are the contributions of different sources, but also underlines the actions which are required to be taken, and how much will be the reduction due to those actions on pollutant concentrations. Now, you can also see the same information in a different way on this bar chart. You can see that on the x-axis you have different cities in the country where air quality monitoring is being done by CPCB, and on the y-axis you have PM10 concentrations, and you can see more than 70-80% cities are not meeting the nationally prescribed standard of 60 micrograms. Now, we must know that our nationally prescribed standard of 60 microgram is quite relaxed if you compare it with the WHO guideline, which is very stringent and is around 20 micrograms. So that means our cities are not even meeting our own national standard, and we are far away from WHO guidelines. The most polluted cities in India are mainly in the Indo-Gangetic plains or in the central eastern part where mining activities are prominent. But the cities of Gujarat are also not very far behind. One of the city which you can see here is Ahmedabad, and it's somewhere here. and shows you a level of about 130 micrograms per meter cube, almost double of the standard. Now, let's see how the air quality levels, PM10 concentrations in different cities have varied over the last 2 decades. This is the data which I've been collecting from CPCB monitoring stations. And for last 20 years, you can see the trends. And also you can see how it compares with the prescribed standard of 60 micrograms. Now see Lucknow, it is always almost 3 times the standards. In Pune, it is almost 2 times the standards. In Delhi, it is almost 4 times the standards, and in fact increased over the last between 2005 and 2011, and since then it is quite consistent. But if you see Surat, where you all are sitting, I think the air quality actually improved in the last decade to some extent, although it never met the standards. But in the last 5-10 years, it has gradually sort of increased in terms of pollution, and that's a thing of worry for all of us. And probably that's why it featured in the list of non-attainment source cities, and we were asked to conduct a source apportionment study, which will be released in the next 2 months. Okay, so similar information can be seen if you see the satellite imageries. You can see thick layer of smoke over the Indo-Gangetic plains towards the West Bengal, Bangladesh, and the whole of this region is quite polluted and can be evidently seen by the satellite images also. Now, this is something which is the result of the computer simulation models which we ran at Terry, and this is the result for summers and winters for PM2.5 in India during the year 2019. And you can see that the concentrations in winters are much higher than what you have in summers. Well, I mean, there are several reasons for it. One is, of course, meteorology. We know that in winters you have much calmer meteorology, and wind speeds are quite slow, and you also have shallower planetary boundary layer height. So boundary layer height is the mixing depth till which the pollution can move vertically up in the atmosphere. And in winters, this mixing depth actually goes down to almost 50 meters, 100 meters at several places in the north of India. And that does not allow the pollution to disperse vertically. And anyways, the horizontal wind speeds are very low in winters, and this leads to accumulation of pollutants in winters, and in summers you have much higher wind speeds. The dispersive capacity of the atmosphere is much higher. You have very high mixing depths ranging up to 1500 meters, 2000 meters, and that this allows high dispersion of pollutants, and the overall concentrations which you see in most part of the country is much lower in summers than in winters. Well, that does not mean that emissions of sources are any lower. It is mainly because of meteorology. The dispersion of pollutants is high, and this leads to lesser concentrations in seasons of summers. There is another reason. In winters you have higher concentration, which is an increase of emissions due to burning happening for heating purposes, especially in the north of India, which is cold, and the temperature go down to less than 15 degrees. You will actually find a need for keeping yourself warm by using electrical appliances. And those who cannot afford electrical appliances, or are not having good access to the electricity, they depend on burning coal, on biomass to heat themselves, and that's why in winters you get higher emissions also sometimes in some areas. So just to show you, daily PM2.5 graph of a Gujarati city of Vapi for 2019, and you can see that concentrations are found to be much lower in summers of April, May, and June, and they are the lowest in the months of monsoon when the rains are there. And as we know, as the rainfall happens, it actually clears up the atmosphere by the rain downwash impact and removes the particles which are suspended in the air by absorbing them on the water droplets. In the winters, as I was explaining in the previous slide, the concentrations go up to probably the highest level in the year, and that's mainly because of low dispersive capacity of the atmosphere, along with some other reasons. Now, some cities also show a peculiar character due to presence of some particular sources. And I can give you this example of Delhi, which actually shows that the peak of pollution in Delhi is not in the peak winters. It is actually in the end of October or in the first part of November. You can see this is the data of 4 stations in Delhi, and you can see that the PM 2.5 levels have gone up to 700, 800 micrograms per meter cube, and the standard is just 60 micrograms. And this is mainly happening because of agricultural burning happening in the upwind states. You have your own sources in the city. You have so many satellite towns which are also contributing, but there is this specific source of pollution which is there in the states of Punjab and Haryana. The farmers, when they harvest their crops, they are left with a lot of crop residues, and due to several reasons, actually they're bound to burn these crop residues, which lead to a lot of pollution, not only to their vicinity but also to the long distances downwind. And over a period of 2 to 3 days, the pollution atmospherically gets transported to the city of Delhi, and you can see this peak, which is formed during these days. Another reason for this particular peak is this festival of Diwali, which in this particular year coincided with the agricultural burning activity, and also due to a particular meteorological event. And when all these three factors combine together, you see the intensity of peak becomes even higher and can lead to very high acute impacts over human health. Now, this is just one exercise to show that it is quite well correlated with the agricultural burning happening in the upwind states. You can see that the concentrations of PM 2.5, which is depicted in green, is quite well correlated with the number of fire events in the upwind states of Punjab and Haryana. I'm sorry, the red line is PM 2.5 and the green line is the number of fire events. As the number of fire events growing, you can see the growth in the PM 2.5 levels of Delhi, and as they go down, you can again see a dip in concentrations to considerably lower levels. Well, as I just said, it is not just about particulate matter. There are other pollutants also, and as for me, ozone is something which is a very critical pollutant of concern for human society. I must tell you that my PhD was on ozone, and what I learned through my literature review is that so many developed countries have already more or less resolved the issue of particulate matter, and the levels in these cities are quite low, maybe less than 10 micrograms on an annual average basis. But the levels of ozone are still quite uncontrolled and unattended. So that means even if you are able to resolve this problem of particulate matter, you will still be left with other pollutants like ozone, which needs to be controlled because they also have a lot of health impacts. They also have impacts over agricultural productivity in your country. As I said, there is good ozone, which is helping us, saving us from the UV radiations of sun and reflecting it back. But if the same ozone is formed at the ground due to reactions of NOx, VOCs, and in the presence of sunlight, well, this ozone is not good and it can lead to a lot of impacts to humans living on the ground. Well, this is a modeled product, and it again shows that in the Indian territory, you have high ozone levels in the Indo-Gangetic plains, and that's mainly because of high intensity of sources of NOx and VOCs present there. The concentrations in the southern and the western part is, and in the northeastern part is considerably lower. Well, if you see the seasonal variation of ozone concentrations, and this is a chart for Delhi, a particular station of Delhi College of Engineering, you will find that this pollutant is quite opposite to what you had with PM 2.5. PM 2.5 was something which was high in winters and low in summers. But ozone is exactly opposite because it depends on the presence of sun. Summer level ozone concentrations are found to be much higher than in winters, and that's why you can see in May, in June, in July, you could see the peaks of ozone and which are quite worrisome because many times this is the period which also coincides with the crops which are lying on the agricultural fields, and it can lead to reduction in crop yields. Okay, so after understanding what is what are pollutants, what kind of pollutants, secondary, primary, and the state of air quality in India, we would like to know from where the pollution is coming to our cities. Well, this is a very interesting concept, and when the air quality debate started in the country, we all used to think that it is only the sources which you can see from your eyes are only contributing to pollutant levels at a particular place. For an example, this is a place in Lucknow city called Gomti Nagar, and there is a air quality monitoring station which is depicted by this circle. So, the earlier way of thinking was that only the area of around 1 or 2 kilometers around that particular station is contributing to the problem. Slowly, we realize that it is not just that small area, but the whole city has some contribution to a particular place in the city. And that's mainly because of the wind direction. Whenever wind blows from a particular direction, it brings a lot of pollution with it, and it can reach to a certain location in the city through the atmospheric transport. Now we move a level up. It is not just the close vicinity of the station, it is not just the city of Lucknow, but it is a much larger region which is supposed to carry pollutants with with the wind flow and impact air quality of so many stations within a city. And we know that deposition velocity of smaller particles is actually low, and that means they can remain in the atmosphere for very large number of days. So if they are less than 1 micron, they can actually keep suspending in the air for many days, and with a normal wind speed of say 5 kilometers, they can actually travel 100 kilometers on a daily basis, and over a period of 4 or 5 days, they can cover 4 to 500 of kilometers. So, in nutshell, this is what I'm trying to tell you. If you are getting, PM 2.5 concentrations of say 140 micrograms at your station, then it will have at least three types of contributions. One coming from the local hotspots, local vehicles, local road dust, someone burning wood, some construction happening nearby. But then a major part will also be coming from the sources which are beyond your eyesight, and the rest of the vehicles traveling on roads of the city, the major industries within the city, the people who may be burning wood or coal in some other parts of the city, All of these may be having some contributions to your urban background. And above all, there is a regional background which is created by so many sources which are not even there in your city. For an example, we all use LPG these days, and uh, LPG is quite cleaner fuel. It does not release particulate matter, and that's why we feel that residential sector should not be contributing to the city level pollution. However, you will find that the moment you go out of the city limits, people are still dependent on using biomass for cooking purposes, and these volumes of biomass burned actually lead to a lot of pollution. And when the wind blows towards the city, all this actually reaches the city level air quality monitoring equipments through regional transport. So, in nutshell, what I'm trying to tell you is, even if you control your local sources, you will not be able to meet your air quality standards. You will need to take into account the sources which are very close to you, which are there in your cities, and which are there in your regions to address the problem of air pollution most effectively. It's just one example, one model simulation run which I conducted long back for the city of Delhi. You can see in the center you have city of Delhi, but the pollution is not just released within the city. There is a lot of it is actually coming from this northwest direction, and so there are a lot of regional sources which impact the quality of air within the city of Delhi. And when we quantified these contributions, what we found was quite amazing. We found that almost 64% of Delhi's PM2.5 was found to be contributed by sources which are not there in city limits. And Delhi itself is responsible for 36% of its own pollution, and even if you stop everything in the city of Delhi, you will still be breaching the standards. Well, I am no way suggesting that city level initiatives are not required. What I'm trying to tell you is that all the initiatives at all levels are required, including city, and then only comprehensive control over air pollution can be achieved.
Hello, sir.
Okay, so moving on to the impacts of air pollution. Well, just to give you a simile, this bar is you can assume it to be a human hair, which is generally of 50 micrometer size, and this big rock is actually one particle of the beach sand, which is generally 90 micrometer in size, and we are talking about particles which are just 10 micrometer in size, and PM2.5 is one fourth of this small particle. So in virtually what we are talking about uh, are the particles which are almost invisible to our eyes, and that's why the measurement, the assessment, the understanding, and the control of pollution becomes very difficult because you're not able to see it properly. See, we can never drink a glass of water which looks dirty, but we just keep on inhaling dirty air because we cannot see pollution or pollutants in the air. And I think invisibility is one of the very important factor which is a hindrance for awareness and for control. Now, why the size of particle is important is shown in these graphs. What you can see are the numbers, and you can see that a particle which is more than 11 micrometer cannot enter our nasal passage. You have nostrils and nostril hairs, and these hairs do not allow a particle which is more than 10 micrometer to enter our passage. So that's a natural defense mechanism our body has. and the particles which are less than 10 can enter our pharynx and trachea, and finally they can start entering our lungs through bronchi. And a particle which is less than 1 micron actually can get into the deepest part of our lung bronchiales, and finally a particle which is less than zero point 0.6 microns can get to a level of alveoli, and these are the places where our natural defense cells are acting. And if you find alveoli macrophage in higher numbers, you must understand that the body is actually trying to fight the pollution which has been inhaled through the respiratory uh, passage. So, in nutshell, what I'm trying to tell you is smaller is the size of particle. It can get deeper into our respiratory systems. If it is very small, it can also enter our bloodstreams and can then flow through the body in different parts. Now, not just the size of the particle, but the chemical constituents of particles are very important. Uh, the PM term is actually it's a term, cumulative term for different types of particles. It can have particles from Earth crustal surface like alumina, silica, calcium, titanium, and iron. It can have particles which are coming from combustion like carbon. It can have particles like heavy metals like chromium, nickel, copper, which are sometimes released from industrial processes. And it can also have particles which are in the form of secondary particles like nitrates and sulfates. And as I mentioned, these particles of nitrates and sulfates are formed when chemical reactions between gases like NOx, SO2, and ammonia happens in the atmosphere. So the toxicity of all these particles is actually not same, and there's a lot of research which is happening to assess the relative toxicity of these constituents. Uh, there are research papers, but still there is no clear consensus which is the most deadliest particle, and what are the different levels of toxicity associated with different types of particles. But certainly, the carbonaceous particles, the particles which are released from combustion-based sources, have shown higher levels of toxicity associated with them. So there are, as I said, it leads to a lot of health impacts. But in terms of numbers, there are some studies which have been conducted, and the recent study has shown us that uh, almost 1.67 million, so 16 lakh people are dying because of high air pollution levels in the country, and this includes both outdoor and indoor air pollution. If you only take into account outdoor air pollution, then 60% of it, that means about 10 lakh people or 1 million people are dying, are attributed to be dying because of high air pollution levels. Now, clearly in the chart shown below, the overall sufferings due to air pollution are much higher than tobacco use and lower respiratory infections, COPD, ischemic heart diseases, and strokes. All these have been linked to high air pollutant levels in the ambient air. So generally, earlier we used to think that only respiratory, lung-related problems are linked to air quality, but gradually what we have understood is that when the lungs are compromised, it actually puts more pressure on your heart to get the same amount of air, and this leads to development of cardiovascular problems, and this is what it leads to. Uh, if you see the data between 1990 and 2019, so almost 30 years of data, you'll find that the death rate due to household air pollution has gone down by 64%. Now, clearly, this is due to indoor air pollution because LPG has penetrated over the last 30 years, and people have moved to cleaner fuels. People have become more aware, and this has led to a reduction in deaths caused by indoor air pollution. But on the other hand, the outdoor air pollution caused by particulate matter and ozone has resulted into an increase of 115% and 139% respectively of deaths happening due to outdoor air pollution. This leads to huge damage of 36 billion US dollars, which is amounted to almost 1.5% of India's GDP, and the states which are facing the brunt of the whole problem are the low income states like UP, Bihar, Rajasthan, Madhya Pradesh, and Chhattisgarh. And that's the problem. These states also do not have great capacities of in terms of health infrastructure to deal with the problems associated with it, and this actually leads to quite alarming, severe situations. This is something which is quite recent and quite relevant to what is happening during these days. Most of us are sitting in our homes, and that's mainly because of the COVID related lockdowns or restrictions. And what has been observed through a number of research studies is that the places which had higher levels of pollution over a longer period of time were shown to have higher mortalities associated with COVID. And this the theory behind is that your lungs are already compromised, and the attack of coronavirus can be more severe if your immunity, if your lung capacities are already reduced. And this is something some research papers have already started to show, although a lot of research is still happening, and we'll need to wait for conclusive outcomes. Then, other than general things which you hear about air pollution on lungs, on hearts, there are new different kinds of health impacts which have been observed by a variety of scientists. What we have found is, this is the paper from IIT Delhi, which actually showed that the exposure to girls, young age girls, leads to reduction in their heights, and there was this number that almost the heights of adolescent girls can get reduced by few centimeters if they are exposed to fire. So it is not only just dying and suffering, or you're also getting impacts of air pollution on different types of in different types of impacts over human body. I mentioned about impacts of ozone on agricultural crops, and this was the study which was conducted by my mentor, Professor V. Ramanathan in University of California. And what they found is that almost 20 to 30% of wheat in India is not at all grown because it is lost due to presence of very high ozone concentrations. And this is quite threatening because the farmer incomes are directly impacted. The overall GDP, the economy of the country, which is quite heavily dependent on agriculture, is also impacted, and this has a good link with the evolution. The impacts on buildings, we always talk about how the color of Taj Mahal is getting yellowish, but there are several other monuments which have faced the impacts of high air pollution levels. Golden Temple is one of them, and I'm sure in the years to come, if we don't control, it can have impacts over tourist activities. I talked about impact on of climate, and this is how it happens. This is the kind of layer which forms over a city. What it does is, on in one way, it does not allow the sun rays to reach the ground surface with the same intensity, and it sort of reflects some part of the sunlight due to the presence of aerosols in the atmosphere, and in this way, it actually cools the Earth's surface. However, there are some particles which are present in the atmosphere which are black in color. They absorb sunlight and warm the atmosphere. So what is happening is your Earth's surface is getting cooler and cooler, while your atmosphere is becoming warmer and warmer due to the presence of aerosols, and it can lead to a lot of changes in the mixing heights, in the planetary boundary layers, and temperature inversions, and can lead to a lot of disturbances in the local regional climate. This is proven again by research studies. On the left hand side, you can see the decrease in radiations at the ground, and you can see due to high intensity of pollution in India and China. This blue patch is actually showing the decrease in radiations on the ground, while at the same place, you will see on the right hand chart high red color showing the increase in atmospheric absorption of energy, and that's mainly because of presence of black and brown carbon, which leads to absorption of heat in the atmosphere. Well, the research is on aerosols impact on clouds, and scientists could find a number of ways through which aerosols can impact the cloud formation. They can increase the rainfall, they can decrease the rainfall. In several situations, it can increase the time for which clouds are going to remain in the atmosphere, the overall size of the cloud, the height of the cloud. So all these impacts are possible if aerosols are present in your atmosphere in plenty. Above all, if you add impacts of different pollution, this is it's quite a dated study by World Bank, which actually at that point of time showed that 8% of India's GDP was getting lost due to air pollution. We were compared with most polluted places in the world, and I don't think as a country or countrymen we would like to do that, and certainly we would like to improve our image on these fronts. And this is something which is close to my heart. I'm a diehard cricket fan, and this is the time when this is probably the first time when I saw an intervention of air pollution on the cricket field. This was a match happening between India and Sri Lanka, and in Delhi, and there was a time when you could see the smog levels were going up, and the masks were taken out by a lot of Sri Lankan players, and in fact they refused to play for some point of time, and that led to a lot of problems during the match. So what I'm trying to tell you is that it's not only health, it's not only climate, it is touching the daily lives of the people now, and in multiple ways, and can be problematic in several ways and needs to be controlled. I would like to take 2 minutes of break, and we'll come back at here only in next 2 minutes. Thank you for your patience. Okay, moving on. I hope I am audible, just to confirm.
Audible.
Thank you. Moving on to the sources of pollution. Uh, See, you know, if I just categorize the sources of pollution in India, you can categorize in terms of on one side they are coming from poverty-driven sources, where people are bound to use coal, people are bound to use biomass for cooking, for heating, and all those kind of things. On the other hand, you have sources which are driven by affluence. So people are driving cars and bigger cars and using polluting fuels. Industries are growing and all those kind of things which are not bad. I'm really not saying that they are bad. We must continue to grow, but there are ways by which emissions can be delinked from the growth, which is probably not happening for all the sources. So if I list all the possible sources, not all, but major sources of pollution in India, this is how it looks like. You have variety of industries, you have transport, you have power plants, you have biomass burning happening in rural kitchens, diesel generator sets, road dust. So when a vehicle moves over a road, a lot of dust gets airborne, and that also leads to dust-related particles. Agricultural burning. So after the harvest of the crop, residues are leftovers and they are burned. Refuse burning. It's a very common problem in several cities. Whenever there is a dump of refuse which is created for volume reduction, for several other reasons, refuse is burned, which leads to a lot of toxic emissions of pollution. Construction sites, we all know how dusty they are and they lead to a lot of dust emissions. Crackers for different festivals, for New Year's, for so many things. Uh, Marriages, crackers are burned and it leads to a lot of pollution. Ammonia sources, drains, livestock, fertilizers, all this lead to release of ammonia. And ammonia is something, as I said, is very important and plays a very crucial role in formulation of secondary particulates. So this is the gas which reacts with NOx and VOCs released from other sources and create secondary particles. VOCs, when you paint your house, when you take a printout, or when you fill your vehicle with gasoline, you can smell something. And that smell is actually nothing but volatile organic compounds, which are not good for human health, and they also lead to pollution of the air. Other than anthropogenic sources, natural sources of pollution are also present, and biological decays, forest fires. Forest fires are sometimes anthropogenic also. Dust storms. All this lead to natural, accumulation of dust. Metrology, as we discussed, is something which is not in our control and is also a very important contributor to high pollution levels. As I explained, in winters, when the metrology is adverse, it leads to accumulation of pollution, and it's a very important factor to be considered. This is a recent, paper which is still under review, and this is what we did. We tried to map all different sources in India at different places, and this is how different pollutants look like in terms of their spatial distribution. You can see that PM emissions are more in the regions of Indo-Gangetic Plain and also in the western region of Gujarat, where industries are prominent. NOx is more evident at urban centers because NOx is something which is related to vehicles and power plants. The places where you have more vehicles are cities, and some locations of power plants. So you can see the dots of red color at those specific cities and power plant locations. SO2 emissions are mainly linked with coal combustion happening in industries or in power plants. So you can see that the industrial zones of Gujarat and Chhattisgarh and Orissa, they show quite high SO2 levels. NMBOCs are primarily released from biomass-based combustion, and that's why the whole Indo-Gangetic Plain, which is heavily dependent on biomass for cooking purposes, is shown to have high NMBOC emissions. Now, if you see sector-wise the same information, you will find that domestic sector residential biomass burning is more prominent in Indo-Gangetic Plains. Industries are having quite a significant levels of pollution in the western region of Gujarat, and of course some places in south of India, and of course places around Delhi. Power plants are point locations where you have the utilities are situated. Transport is more located at the city level. You can see Bangalore, you can see major cities of Mumbai, Delhi, metros basically showing higher levels. Agricultural burning, I mean, it's an interesting chart. You can see that Punjab is the state which shows much higher levels than rest of the country, and that's mainly determined by satellite-based detection of agricultural fires. Now, what we did was we put all the emissions in the model and tried to see what is the contribution of different sources towards prevailing ambient PM 2.5 concentrations. And this is how it looked like. That residential, if I take an average of whole India, domestic sector, residential sector is contributing to one third, 30% of our problem. And in cities we don't see people burning wood so much, so we tend to ignore this source, but this is something which is creating a background of pollution for so many cities in the country, and is responsible for one third of the total average pollution in the country. After this, you have industries contributing to 16%, power plants contributing to 7, transport 7%, agricultural residue burning 8%, and then you have a mammoth 19% coming from outside of India. Now, this is something we generally tend to, you know, uh, we don't even think about it actually. We are not ignoring, we are not even thinking about it. See, we have a big landmass attached to our neighbors. We have Pakistan, Afghanistan, Gulf countries, Nepal, Bangladesh, all of them very closely attached to our boundaries. And and they are also having the similar kind of sources. And it is when the wind blows towards our side, we get the pollution from all these countries, and that is why almost 19% of average pollution in India is caused by international sources. So this is how it looks like in terms of sectoral contribution. You can also divide the pollution into primary, secondary inorganic, secondary organic, and you will find that secondary particles have a dominant role. Primary particles are only 38%, but rest 62% are attributed to secondary particles in the country, which includes both secondary inorganics and secondary organic particles. Now, here there is an interesting thing to see that transport is only contributing to 7%. We must not forget that this is a chart for whole of India. It's an average chart for whole of India. So that's why the contribution of transport sector is limited, 7%. The moment you go to cities like Delhi, Bangalore, Pune, Kanpur, the contribution of transport, which is these blue bars at the bottom, is very high. It goes up to from 15 to 45%. So that means the more you get closer to the cities, the contribution of transport type of sources will increase, and the contribution of residential biomass burning kind of sources will decrease. This is the latest study which we did. I'm so sorry. This is the latest study which we did for Delhi and we found that for 2 seasons, summers and winters, the source contributions were very different. And in winters, transport vehicles was contributing to almost 28%, while in summers it reduces to 17%. And the contribution of dust is very, very high in summers, because of wind speeds. You have high dust influence from faraway regions, and this lead to higher contribution of dust in summers. But in winters, it is the vehicles and industries which are dominant. Now, another very interesting finding was that industries were contributing to 30%. Now, in Delhi, some of you may be knowing that most of the industries have been asked to either shut down or were asked to relocate themselves outside of the city limits. But despite this, the contribution of industries was coming out to be very high, and that's mainly because of regional scale atmospheric transport. So the industries were relocated to a location outside of city, but when the wind is blowing towards this side, it brings the pollutants back to the city, and the benefits of relocating industries were lost. We also did subsectoral distribution. So like within transport, you can divide the contribution of trucks, two-wheelers, cars, so that you know which vehicle is to be targeted. Like in case of Delhi, it was trucks and two-wheelers which are contributing in huge quantities. And that is why when the odd even scheme was launched in Delhi, we could see a very small impact on pollution concentrations, because the scheme was focused only on cars, which was having a very small contribution in the overall PM 2.5, and hence you could not see a great impact on the PM 2.5 levels. Similarly, for industries, you can see what is the contribution of brick industry, contribution of stone crushers, other industries, and then you can take pinpointed decisions. The idea is to provide all the possible information in front of a policymaker, so that they can take decisions which can help control pollution at a certain place. Like PM, you can also carry out source apportionment of ozone, and this is a published paper which I published a few years back, which shows that all different sources in India are contributing to 30% of ozone concentrations, and rest is actually coming from outside of India. So that means unless we have international regional cooperation, it will be very difficult for us or for any country to control ozone, and that is why hemispheric, transport of ozone is now being talked about. And we need to control our own sources, but we must also need to discuss it with our partners, international neighbors, to reduce pollution at their territories, so that a comprehensive control of ozone can be achieved. This is a ozone source apportionment study which I did in my PhD for Delhi, and it shows again the yellow portion is actually the background which is coming from outside of the city, and you can see that almost 80% of ozone in Delhi was found to be coming from outside of the city limits. And you can see these peaks happening in each day, and that's mainly because the sun is coming out and then going down. So when the sun is out, ozone concentrations go up, and when it goes down, it basically goes down. So you can see that most of it is actually coming from outside of city limits, and only few sources like transport and power plants were contributing to ozone formation to some extent in the city. Now, there is an important thing which every air quality modeler should do, is to predict the future. Models give us this opportunity to not only assess the current share of sources, but it also gives us an opportunity to peep into the future, to understand how would the future air quality look like, and this is what we could do for the case of Delhi. You can see that we created three scenarios. The first scenario, blue line, showed that the current levels of 109 micrograms can go up to 155 micrograms if no measures are taken. But if we go ahead with the current plans and policies and we called it BAU, the pollution levels will stabilize and will only increase from 109 to 118. However, this will still be much higher than the standard of 60, and that's why additional measures are required. And if you take additional measures, you can actually achieve ambient air quality standards in a city like Delhi. And this is what we try to see, taking into account how the city is going to grow, how the new controls can be employed, and where will you go in terms of air quality if certain kind of growth happens within and outside the city. Okay, so let's now move on to solutions to improve air quality. And I would like to start with this chart. It's a very interesting chart. One of my ex-colleague, Astha, and her associates did that. And we did this analysis for 4 cities. And we compared the PM 2.5 concentrations in 2 years, 2019 and 2020. Red dots are 2020, blue dots are 2019, and during the period of lockdown and pre and post lockdown periods. You can see that during the lockdowns in all the 4 cities, red dots are below the blue dots, clearly telling us that there was a significant improvement in air quality during the period of lockdowns. It was also it was quite visible that the skies were much cleaner during the lockdowns, and we could see that air quality improvements can be achieved if sources are controlled. However, we really don't recommend to enforce lockdown, to cut down on industries, to reduce vehicle movements. So we are really not saying to decrease or reduce the economic growth. I think for ensuring good quality of life, the economic growth should continue. However, we need to delink the economic growth from emissions, and we need to grow more sustainably so that pollution does not grow and only the quality of life, only the socioeconomic status of people grow further. This is a specific chart for Delhi, and it also shows similar kind of relationships during lockdowns. And we found that 43% of PM 2.5 and 60% of NOx was reduced in Delhi during lockdowns. However, despite this reduction, we could still find the levels of pollution in Delhi which were beyond the standards. Now, try to understand the situation that in Delhi, and I'm talking about April, May 2020, when it was the lockdown was very strict. Vehicles were not moving, in plenty, and you have all industries closed, nobody is going to offices, but still the level of pollution was there and it was above the standards. So we did this source apportionment study to understand from where the pollution is coming to the city. And this is what we found, that industries which were still operational outside of city limits, agricultural residue burning in the upwind states, the secondary particulates, the waste burning, the biomass burning which is happening in rural kitchens continued even during the times of lockdowns and kept on polluting the air quality of Delhi. And that's why the regional scale pollution control is very important, and only controlling pollution within the city limits will not suffice. You will have to have much larger airshed based regional controls employed for control of pollution. Now let's see the list of things, some of these things which have been done in our country for control of pollution. Now we have a National Clean Air Program. You must all be aware about this, and we have taken up a target of reducing PM concentrations in the country by 20 to 30% by the year 2024. We are penetrating LPG and PNG at a very fast pace under the Ujjwala scheme, and we have electrified our villages through the Saubhagya scheme. India is probably the only country which has moved from Euro 4 to Euro 6 vehicular standards. We are trying to reduce agricultural residue burning by promoting happy seeders, by promoting other microbiological solutions to mulch the residues in the soil. We have introduced a variety of emission control norms for power plants and industries. We are trying to expand gas as a industrial fuel, as an automotive fuel, and we know in Surat a lot of industries are using gas, vehicles are using gas, and of course on the awareness front, India came up with its own air quality index, which was good in my opinion to spread awareness on this issue. However, despite all the measures taken, we could not see a great decline in pollution levels. Only in few cities you can see here and there some small reductions, but on a broader scale, you cannot say that the air pollution has really reduced dramatically in several cities. And the reasons were probably measures were taken, and we acknowledge that, but probably they were not enough. They were probably inadequate. I mean, some of them could be reconsidered. Probably they need time. I mean, Euro 6 is something which will take time to perform. And sometimes they are not enforced. For an example, India introduced emission norms for power plants for control of SO2 and NOx, but they were not enforced yet. And I think that's one reason, all the measures were not successful. So, I mean, this is something which we proposed to the government some time back, and some of them were taken very seriously, hitting different sectors for control of pollution, for different types of pollution. And we started, I remember in 2016, we were probably the first voices in Terry at that point of time, which raised this issue of National Clean Air Program, NCAP, and we talked about regional scale control and going beyond the boundaries of the city, and more scientific air quality management through monitoring and source apportionment. And all of these things have been now adopted by the government. We now have NCAP. The government is carrying out source apportionment studies for most non-attainment cities, and also now they are considering, to adopt regional scale airshed based approach. So, if I see the progress made, as I said, source apportionment studies have been initiated. The air quality management plans are being finalized for many cities. The monitoring network is extending. The LPG penetration is happening, and there are some lagging issues like prioritization and processing of budgets. Now, a good amount of almost 4,000 crores have been given to different cities for control of pollution. But to prioritize the spending of this budget is not being done. We are spending it on few things, but we really don't know how much this is going to benefit, and we don't have an action plan in place, which clearly tells us that this is the most cost-effective way of controlling pollution in the cities. Agricultural residue burning is still happening. In fact, in 2020, it was much higher than what we had in previous years. So this is an unresolved issue. Older vehicles is still a problem for us. We have fixed Euro 6 for new vehicles, but unless we control pollution from older vehicles, this is going to continue for at least 5 to 10 years. Electric vehicles, I think we are moving on a snail's pace at the moment. Two-wheelers, we can still see some electric vehicles moving, but cars, for buses, for three-wheelers, there's a lot to be done. LPG is penetrating, but I think there is still a large population base which is burning biomass, and some of them are poorest of the poor, and we need to devise new economic-based ways to address these issues and to reach out to these people with cleaner fuels. A few things on specific sectors, like for transport. I remember when India was discussing this move towards Euro 6 standards, we provided this cost benefit analysis. I think this is how policymakers can be influenced. If you show them the costs and if you show them the benefits, and if the benefits are outweighing the cost, like it was in this case, you can actually convince them with an economic argument that this is beneficial for the country to go in this direction, not just for air pollution but also economically. Now, this is another concern which we have observed in Indian cities. We monitored speeds of vehicles in different cities, and you can see that the speeds of vehicle and uh, there were three types of vehicles which were monitored: bike, car, and bus. You'll find the speeds are varying between 10 to 20 kilometers per hour, and that's not good enough. And this means there's a lot of congestion, and vehicles are not running on their optimal efficiencies, which will not only lead to pollution but will also lead to lot of fuel loss due to idling, due to creeping. And of course, this is also evident in this graph, which actually shows the test cycles of driving in the red dots, and the blue dots are the real world driving conditions, which are far, far more different than the test cycles. And this means not only we need to reduce congestion, but we also need to test our vehicles on a real world emission testing scenario, and not based on lab-based test cycles. There's another thing which is related to transport, is the shift from rail-based transport to road-based transport over the last 50-60 years. Since independence, the share of rail-based trade transport has decreased, and that's a worrisome situation, because rail is far, far more efficient in terms of energy efficiency for freight transport, and this is seems to be going down since then, and the road transport has gone up, which leads to pollution and inefficiencies. Other than this, the issue of inspection and maintenance, fleet modernization, all these things are important, and needs to be done at the national level to ensure that older vehicles or the in-use vehicles which are there, they do not emit pollutants in plenty and remain in control. In the residential sector, I think the issue is about penetrating LPG further, and wherever possible, if we can penetrate electricity, that will be even better. And it's not that it's not happening; it is happening at a quite decent pace, but still, a lot of people are still dependent on biomass, and one important reason for that is the affordability of LPG is still not there, and the subsidies which are giving on the cylinders are probably not yet good enough for a certain class of people who are yet not able to afford this on a daily basis. So I think more cross subsidizations are required, and probably that can lead to uptake of LPG and in these sections, and can help reduce pollution. Agricultural burning, it's a classic problem in state of Punjab and Haryana during the months of October and November. Uh, you know, it's not that nothing is happening, but despite that, a lot of fires are detected through satellites. We need to have more extensive in situ and ex situ management things in place. We need to develop business models for collection, transport, and storage of residues. And of course, the waste to energy plants can be one of the keys for monetizing these residues. In fact, power plants of NTPC have initiated these tenders to collect residues and burn it in the coal-based power stations in the north of India. For industries and power, I think the key here is enforcement. There are a lot of standards which are in place, but they are not being properly complied with. And one of the reasons for lack of enforcement is limited capacities in our state pollution control boards. If you go to these SPCBs, you will find that there are very few people who are sitting and who have these duties of managing thousands of industries in the state, and it is humanly impossible for them to probably control them through physical visits. So we need enhancement in capacities, and also probably the use of technology. The real-time monitoring of industrial stacks is something which can be used to supplement manual enforcements. Emission trading schemes. Surat is one example where emission trading scheme was tried out and was quite successful as far as I have heard. Uh, but this is another economic instrument which helps controlling emissions from an industrial cluster. Dust and waste. So a lot of waste is generated, and it is accumulated in landfills, and methane comes out of these landfills quite openly, and adds to the overall pollution levels. Methane is something which also leads to ozone pollution, and so the recovery of methane is an essential step. If you can recover methane from the landfills, it can be used as a gas for some useful purpose, and you will in the process help reducing pollution. So if you take all these measures and try to see how would India look like, this is how it looks like in the model. If you don't do anything, India looks very very polluted. But if you employ these 10 solutions which we discussed, most part of the country can become much greener, and it can lead to reduction in pollution levels. Same things can happen in Delhi, and if we take right measures, pollution levels can be drastically reduced in the city of Delhi, and there is a possibility that we can achieve our national ambient air quality standards. These are the list of strategies which we gave to the government of Delhi and also to CPCB on how to control pollution in Delhi. And there are a number of things which we prescribed, and some of them have already been taken up by the government. Okay, so I will also talk about what are the linkages air quality is having with climate. And initially, I spoke about different types of particles having different impacts on our atmosphere. But what is the broad story? So this is what this chart shows us. See, this is the chart of temperature rise happening across the world due to rise in GHG emissions. Now we are somewhere here, and we have already increased the temperature of our Earth by 1 degree Celsius. Now, if you don't do anything from here, you are bound to hit almost 2.5 degree rise in temperatures by the end of 2070 or 2080. But if you take measures for control of CO2, which is a greenhouse gas, your temperatures will increase by 2 degrees Celsius. However, if you take measures along with CO2, you also take measures for SLCPs. That means you also control black carbon, you also control methane, you also control ozone. Then your temperature rise will only be 1.6 degrees. So that means if you take into account air pollutants, you can actually reduce your global mean temperature rise to some extent. And we know that this temperature rise is quite detrimental, quite scary, and can lead to tremendous impacts over human society. So our objective should be to keep this global temperature rise within a limit, and SLCPs can play a very important role in this context. Now let's see what are the contributors to CO2 and PM2.5. Now CO2, you can see the power plants and industries are the major contributors. power plants which are burning coal, and we know that the efficiency of coal-based power plants is not high, so you have a lot of CO2 emissions coming out of power stations. But because electrostatic precipitators are installed at most of these stations, their contribution in PM 2.5 is very small, and you have industries and residential sector emissions contributing. So the point is, CO2 is contributing to climate change. PM 2.5 is mainly contributing to local health impacts. Can we draw some synergies? Because the sources are similar, their contributions are different. So if we can draw some co-benefits out of the same strategies, then we can actually hit two birds with the same arrow. And however, the benefits will definitely not be linear, will not be proportional, and we need to estimate, we need to assess which are the strategies which can provide the maximum co-benefits in terms of air pollution reduction and climate change mitigation. So, there are a variety of things you can do. For an example, if you move to renewables, so not only you are reducing the coal consumption, not only you are reducing CO2, but you are also reducing air pollution. If you move to higher energy efficient technologies in industries, you will reduce coal consumption there. You will reduce pollution, you will reduce GHG emissions. If you move to electric mobility, you are going to reduce diesel consumption. You will improve the efficiency of vehicles, and CO2 emissions will go down along with pollution. So there are a number of strategies which can provide a lot of co-benefits to both climate change mitigation and air pollution reduction. This is a study which we did, which actually found that if India moves to a low carbon trajectory and stick to the nationally determined contributions, India can automatically reduce PM 2.5 concentrations by 13%. So just moving on a low carbon pathway in pursuit of low GHG emissions, you will end up reducing air pollution also to some extent. Okay, I'm just moving to my last few slides on recommendations. First, let's start with the individual cases. As an individual, the first thing we must do is to demand better air quality. Unless we do it like clean water, like clean aesthetics, like the good roads, unless we demand air quality in that spirit, it is not going to be given, because it's all sort of driven by political motivation, which actually comes from demands from individuals who are there. So I think demanding good air quality is first thing we must all do. We must try to reduce our energy consumption. We must try to reduce our exposures, especially during the times of high air pollution episodes. We must try to use masks, and COVID has taught this quite well. Maintaining vehicles. I mean, we tend to overlook this fact, but if you're not servicing your vehicles quite frequently, then you will end up losing a lot of fuel and also generate pollution. We must buy low emission products. We must avoid burning stuff unnecessarily, and we have to be vigilant of our surroundings. I mean, there are so many things happening around us, and we must report if we can see violation of air pollution laws and rules. And of course, we must spread awareness and plant more trees. On the government side, these are the 10 recommendations which we have given to the ministry to consider for improving the National Clean Air Program. We advocated for regional scale assessment other than the city level ones. We requested for more assessment and control of secondary pollutants. We all are focusing on primary part of particulate matter, but there is a lot to be done on the secondary side of particulate matter. We need speciation network to track progress of different constituents of particulate matter. We need to integrate policies for control of both air quality and climate. Prioritization is sort of missing at the moment. This is what I mentioned, that we have now money to invest, but where to invest? Which strategy needs to be prioritized over the other? That is something that needs to be done. Developing business models for implementation. Use of low-cost models. Now, like low-cost sensors, we have low-cost forecasting models, spatial mapping models which are present, which can be used for assessment purposes. And then we have to strengthen the enforcement through technological support, and of course we need to keep enhancing budgets till we are in a position where we are able to control pollution. Some of the innovation needs are also required. We are talking about electric vehicles, but electric kit retrofitment for existing vehicles can be thought about. The batteries are still very expensive, and it is at the moment beyond the reach of common man. That's why electric cars are so expensive. And I think improvements in these batteries can be a game changer. Remote vehicle emission checking. The PUC system currently we have is not great in context of Euro 6 vehicles. We need to have better systems in place. Low-cost technologies for stack and ambient monitoring. Some technological improvements for construction dust control. Low-cost masks and purifiers. I think, we all rich people are able to buy purifiers. What about people who are poor, who cannot afford a purifier in their house? Until then, till their quality is improved, they are bound to be exposed to such a high level of pollution. So all this is what I wanted to say. Just leaving you with some key unanswered questions. We know that NCAP is a very good program which we started in this country. The targets given are in the range of 20 to 30% reduction by 2024. The question is, are we all set to achieve these targets in the next 2-3 years? Do you think there's a scope to increase these ambition? Do you think the ambition needs to be raised? Are we really delinking the economic growth from emissions? Are we in position to improve our enforcement capacities? Are we taking into account the overall carrying capacity of a city or not? So all these questions keep coming to my mind, which to me are still unanswered, and we will need a lot of people. And probably this workshop today is one stepping stone, which probably will excite a lot of people like you, who will keep on working in this space for the years to come, and give your contributions to improve air quality in our great country. So with this, I will just end by saying that we need to believe in science, we need to use the science, and we need to implement the science to get rid of this problem of air pollution. We need, by believe, I mean you need to understand from where the pollution is coming. We need to acknowledge the problem. We need to very scientifically, in a very scientifically way, tell what solutions can be used. And of course, using it is most important after believing. And finally, implement those solutions which are scientifically proven, which are derived through proven scientific methods, so that you get good results on the ground. So with this, I thank all of you, the organizers, Dr. Zariwala, and all the faculty of SVNIT, and all the students and the participants for this, and giving me this opportunity to present my views on this subject. Thank you so much. I look forward to your questions.
Thank you, sir, for very alarming presentations, because you have correlated your studies with a source apportionment results, whatever the study you have done it in your career. I request all the participants, if you are having any questions, you can directly unmute yourself and ask the question to sir directly. I can see some of the questions in the chat box. Uh,
Good evening, Namrata Madam. Good evening, sir. Sir, I would like to appreciate your presentation. It was wonderful and very informative presentation you deliver, sir. I have one question. You have predicted, you given the data of past particulate matter and the future prediction. So, what is the best prediction model or the forecasting model for particulate matter best for India, basically?
Very good question. Can you identify yourself? Are you from Surat?
Myself, Akshay Chauhan, I'm working as a research full-time research scholar at SVNIT Surat and working in the area of similar aerosol and particulate matter prediction. So I would like to just I would like to get the basic information, sir.
Yeah, yeah. Thank you, Akshay. I think very good question and very pertinent one. See, there are a variety of models which are available. You need to pick and choose the right one for your requirement. See, if you want to predict air quality for tomorrow and day after, I would say a statistical model or something like artificial neural network, which is based on say machine learning, will be probably more accurate, more efficient in giving you very good results. But if you want to predict, medium to longer term air pollution levels, like what is going to happen 2 years down the line, or maybe 6 years down the line, then you will need more sophisticated models which can take into account atmospheric processes and changes in emission characteristics, and then you apply those. There's also a question of at what scale you want to apply the model. If you just want to do city level modeling, then a model like air mode could be very good use. It could be very good for dispersion modeling purposes. But if you want to take into account what is coming from outside of your city also, in a nutshell, if you are wanting to use a regional scale air quality model, then you must use something like CMAC, which I used. A lot of people use WorfChem, which is also a very good model. Some people use ChemX, that's also a very good model. So these models are regional scale chemical transport model, which comprehensively take into account regional scale meteorological variations and also emission sources. So to answer your question, it will depend on what you want to do with the model, and then you can select an appropriate model for that particular purpose.
Yeah, thank you, sir. And one more question, like suppose I want to forecast for a particular city. Suppose I want to forecast for a Surat city. So approximately how many years of data is required if I want to predict for next 1 year? So ideally, how much historical data should be available with us?
See, historical data sets are required in the statistical models where you need to make the model learn, and then you predict for next few days. If you want to predict for next 1 year, then I think you will basically need the current emission inventory and the projected emission inventory for next 1 year, and then projected metrology for next 1 year to take into account what is going to happen in next 1 year. If your time frame is so long, it's 1 year, then you cannot use statistical model, and you don't need past data sets for this purpose.
Understood, sir. Thank you.
But of course, for dispersion model also, you need to validate your model. So maybe 1 year of validation for last 1 year could be required. So in that sense, you will require last 1 year of data
Okay.
uh, to validate your model predictability.
Understood, sir. Thank you, sir.
Is there any other questions from participants? Okay. Sir, I have one small question. Can I
Ji,
ask?
yeah,
Yes.
please, madam.
Yes, sir. When we are going for the health related studies, when we are correlating the air pollutions and health related studies data, so generally the data are available like health related data means hospitalization or heart attack deaths. So that is available overall. So how to correlate it with air pollution data?
That's again a very, very good question. See,
Hmm.
I'm really not an epidemiologist, but I know what they do. See, you're right. If someone is dying because of respiratory illness or due to a heart attack or a stroke, that does not necessarily mean that he is dying just because of air pollution. There could be so many confounding factors which must have led to this kind of an outcome. So when you do these kind of studies, you study all those cases very, very deeply. You take into account what is the history of that person. Was he a smoker? What was his where was he living? Was that location a polluted location or not? What was his habits? What how he was traveling, and all those kind of information you try to get to remove all the compounding factors which can interfere with the kind of research you are trying to do. So after removing those compounding factors, whatever is remaining, that is something which you attribute to air pollution levels, and then you can say that within certain confidence that this is the real impact of air pollution on human health.
Because generally for a foreign studies, generally the baseline data are available, but in Indian situation, I think it is somewhat difficult to get the baseline
Very
data.
difficult, and that's
Very,
one reason we do not still have our own dose response curves in the country.
yeah. So thank you very much. I think there is a one question. Which model have you used for the mitigation strategies? I
So
think.
in my career, I have mainly relied on CMAC, Community Multi-Scale Air Quality Model. It is a very comprehensive, state-of-the-art air quality chemical transport model, which takes into account, regional scale metrology, regional scale sources. It can take into account, the outputs of global models to see what is coming from outside of India to India. So a lot of things. So I think to answer your question, CMAC is something which I used.
Okay. So I think so. Majority of the questions you have answered. Sir, once again, thank you very much for giving your valuable time and interact with the participants from SVNIT Surat. So, again, we will be having in near future more interactions with you all. Okay, thank you, sir.
Thank you.
Thank
Namaskar.
you, sir. So, all the participants, we will be meeting tomorrow again at 10 a.m. sharp. Thank you all.